All right, so for day 4, this is curve of best fit. Make sure that you're doing exactly what I do on my calculator, because if not, you're going to be confused. We're also going to skip around because there are some things that have changed this year that you guys won't need to know. So I'll just skip around them. All right, first, this part is very important. This entire box basically tells you what you need to know and how you need to find it. So let's start with the most important, which is turning on your diagnostics. So everyone grab their calculator. Let me close some things out. Okay, so grab your calculator, hit second 0. And make sure you have a catalog that comes up that looks just like this. You guys have this? All right, you're going to scroll down till you get to the D's. So scroll down and down and down. And you see the little arrow that's moving? You want that arrow to be beside the words diagnostics on. Okay, so you're gonna see where it says diagnostic on. You guys have that? All right, hit enter until you see the words done. If your diagnostics is not on, then this whole thing is for waste, because it's not going to tell you what you need to know. Okay, so make sure that's on. Okay, if you ever reset your calculator, it will turn it off. You just have to do it again. All right, go ahead and clear it out. We don't need it for now, but it's on and it's waiting. The next part of this, step 1, 2, and 3, basically tells us how to enter the data that we're going to be entering, how to graph it, and then how to get the equation that we want. All right, so it says, remember, look at the value of the correlation coefficient. All this means is to look at your R. We will talk about our R often. To determine the line or curve of best fit. In Algebra 1, you guys did the line of best fit. In Algebra 2, we call it the curve because we have more than one line. Our graphs look very different. They're not just a regular straight line anymore. All right, you always want to look at the last line to determine what the R or the R2 value is. Underline that, highlight it, do what you want, but make sure you know that we have an R and an R squared. Whatever that last line tells us, that's what we're looking at. The closer the last line is to -1 or to +1, the better off you are. So once we start comparing different regressions, because there's 6 of them, once we start to compare different ones, we're looking at our R, which tells us which one we want to use. That tells us our line or curve of best fit. All right, there are 6 different shapes your data could look like. All right, so normally we use like straight lines for this, but now we're talking about data. So I'm gonna basically put dots which show different amounts of data. For linear, let's say these are all just data points, but for a linear graph, it will be in a straight line. So make your dots appear in a straight line. That will be for a positive set of data. And this would be for a negative set of data. It doesn't matter how many dots you use, as long as you're showing that if we were to draw a straight line through that, you would see that it would be linear. Linear is also x to the first power. That is important. You need to know what you're looking for. Okay. Quadratic, we've seen before. This is x squared. So my shape for quadratic is called a parabola. So that means it's like a big U. And I'm going to just draw some points around it. That'll be for positive data set. For negative, my U will be upside down. All right, for cubic, this is x cubed. For cubic, we're basically, our data points will look like a snake. It looks like a snake. It either goes up or it goes down. Goes up or it goes down. For quartic red, that's going to be x to the 4th power. What this looks like is basically either this is actually the negative one, a W, or it could look like a N. All right, exponential. This is a little different. How do we know what's exponential? How do I know that my function is exponential? There's a saying that we said earlier in, I think, day 2 or day 3. If it's exponential, you know because there is an x in the what? Just tell me you remember. An x in the exponent. If it's an x in the exponent, well then it's exponential. What type of asymptote do I have? Horizontal or vertical? Thank you. Horizontal. So that means if my asymptote looks like this, my data set could look like that. Or it could look like that. I get really close to my asymptote, but I don't touch it. And for logarithmic, I know it's going to be log because it either says the word log or it has ln for natural log. And I have a vertical asymptote. So that's my asymptote. And my data point, my data set will look something like this. Those are my options. Do you notice anything different from the first 4 and the bottom 2? What's the difference between the first 4 and the bottom 2? Yeah, well, you notice that the first 4 are all until the power or something, right? So we call these, write this down, the powers. The first 4 are known as my powers. All right, take a look at number 1. Which scatter plot is best modeled by a quadratic function? Quadratic is going to be x squared, so that means it looks like a parabola. Okay? If I were to sketch these graphs, would A be quadratic? No. C is also not quadratic. B kind of looks like it. And then there's D. Which one of these would be quadratic? B. B would be the best answer. On number 2, which type of function is best represented by the scatter plot below? I'm going to try to connect my dots. Which one of these would this be? Cubic, exponential, linear, or quadratic? Huh? Cubic. It would be cubic because of my shape. All right, number 3, which type of function best models data in the scatter plot below? This one's a little tricky. What does that look like? It looks like quadratic, but that's not an option here, right? Well, we know it's not linear, that's for sure. It's not a straight line. Quadratic is classified as a power, so that's the one that we choose. It's not saying that it's quadratic exactly, but we know it is because it is considered a power. It could have been exponential if this last dot wasn't there, because it looks like it will be getting close to an asymptote, like here. But that last dot there skews it away. It kind of shapes it differently. All right, Diane put a set of data into her calculator and found the following regression functions. Based only on the correlation coefficient, which is also known as R, which of the regression functions would appear to be the best fit of the data? In order to find the best fit, we need to find which R is closest to either -1 or +1. So first, let's look at all these R's. Which one is closest to either -1 or +1? Well, they're all positive, so which one is closest to +1? What did you say, Michaela? D. D is the closest because it's 0.97. The others are 0.96, 0.85 is definitely out. 0.93, and so 0.97 is the highest. Then it says, what type of regression is this? So take a look at your equation. My only hint to you is that there's an x in the exponent. What kind of function would that be? We have linear, quadratic, cubic, quartic, exponential, or logarithmic. It's exponential because there's an x in the exponent. Exponential. Any questions there? All right, so tips and tricks for regression problems. The first tip is if they tell you what function the regression is, you only have to check that one. The next tip is to only check the functions that are in the multiple choice answers. What this means is to fully read what it's asking you to find. If you read it, then you'll be able to see. So let's take a look at number 5. One of these tips will come in handy. The amount of lost revenue from tickets not sold for a concert is shown on the table. Ticket prices include tax. Okay. The question, which equation best models the relationship between the amount of lost revenue, and the price per ticket? Price per ticket. That's what I'm comparing here. Did they say anything in my question about the number of tickets sold? No, this is just to confuse you. You don't even need this information for this problem. I would just cross it out. You do not need it. All right, so part of your tip says to look at your answer choices, determine which regression it is, and then only check those functions. Well, look at A. What type of problem is this with the x and the exponent? This is going to be exponential. What about B? Exponential. What about C? X to the first power. This is linear. And same with D. It is also linear. So I don't have to check the R's for everything. I need to check the R's for exponential and for linear. Okay? If you don't know that, you'll go through your calculator and check all 6. You don't need all 6. You need 2 of the 6. So grab your calculators. I need you guys to be writing exactly what I write, or I guess typing exactly what I type. Alright, so first what we're going to do is we're going to hit stat. These are the directions that's on the first page of notes. We're going to hit stat, and then we're going to hit enter for edit. If you have numbers in your L1 and your L2, go ahead and highlight L1, hit clear, and then scroll down and it disappears. Do not hit delete. If you hit delete, it'll take away a whole column. I do the same thing for L2. I hit clear, and I scroll down, it disappears. Or you can clear it out manually, like one by one. Alright, so if you look back at the table here, I'm going to consider this my L1 and this my L2. That's what I'm comparing. So in my calculator, in my L1, I'm going to type in the price per ticket. So that's 25, 35, 55, and 125. And then for my L2, the amount of lost revenue, I have 2,100, 2,800, 5,060, and 40,325. When you type these in, make sure that you're typing the numbers in exactly as they're supposed to be. If you have one little mess up, or you forget a 0, or you forget a decimal or something, the whole thing is wrong. All right, we have all our numbers in. Hit stat. Scroll over to calc. And if you start with number 4, you'll see all the 6 that we've been doing. We have linear, quadratic, cubic, quartic, skip number 8. Number 9 is for our log. And then 0, which if I keep scrolling, you'll see it. 0 is exponential. So I only need to check the R's for linear and for exponential, right? What I have to do first is go highlight number 4 for linreg, that means linear regression. Hit enter until it calculates. And you should have all this information. Do you guys have this information? Okay, so what we are looking for, we're looking for this last number. Our last line tells me my R, because I need to compare my R's first. So this R, which is your regression, is 0.977. All right. You don't have to just write down on your paper somewhere that linear was 0.977. Go back to your calculator, and we're going to hit stat, go over to calc, and now I need exponential. So I'm going to scroll down. To exponential red, or you can press 0. Hit enter until your information calculates. All right, once it calculates, let's look at my R, which is 0.999. Which R is higher or closer to 1? It's exponential, right? Exponential is higher because linear was 0.977. So I'm going to cross out C and D. I know that will not be my line of best fit because it has to be exponential. Now that we know it's exponential, stay looking at your calculator screen. I need my A to be 997 and my B to be 1.03. Which answer would that match? A or B? It matches B. And that's my answer. So what we had to do is we had to compare R's. So we looked at linear, looked up exponential. We knew the exponential was higher. So that's my line of best fit. And then we compared my information. Any questions there? All right, look at number 6. The table below shows the sales of the Gizmo 9000 from the Orange Computer Company, where X is the time in weeks since the Gizmo's release and Y is the number sold. Using an exponential regression equation about how many Gizmo 9000s will sell by week 7. This is what I mean by read what they're asking you to do. Which regression do I need? I'm only going to check exponential. Okay? They told me I'm only using exponential. This is my L1, my Y is my L2. Grab your calculator and let's put this information in. So hit stat and enter. I'm going to clear out my information first. Okay, so for my L1, I have 1, 2, 3, 4, and 5. And for L2, I have 15, 24, 24, 17, 41, 90, 54, 66, and 75, 01. Okay, make sure your numbers are right, double check them. All right, now let's calculate it. Let's go to stat, over to calc. They already told me that we're checking the exponential regression. Exponential is 0. Let's calculate what we get. Alright, so here we go. Do you guys notice this first equation up here, right? That's basically our basic equation for exponential. A times B with an x and the exponent. Alright, what's my A? You see A is 1093? So let's plug this in. So 1093 times my B is 1.49. Then I need an exponent of x. Well, we're trying to find what my week is. So my x is going to be 7. That's what I'm trying to find. I'm trying to find how many we're going to sell by that 7th week. So go back to your calculator. You can hit second mode to go back to the normal screen. And I'm going to type in 1093 times 1.49 to the power of 7. You all get 17,820. Okay. Your decimal may be a little different depending on how you round it. But nonetheless, you get y equals 17,820. Which answer is this closest to? F, 18,000. All right, we're going to start skipping around. We're going to skip number 7. We're going to skip number 8. Let's look at number 9. On number 9, it says, is the model for best fit for this data linear, quadratic, logarithmic, or cubic? So we have L1 and L2. For the sake of time, you do not have to put these in your calculator. Okay, so if you're doing it now, just wait a second. So let's imagine that we're doing this. Let's say that we type this top line in my L1, the second line into L2, right? And then I want to find all of their regressions. So we're going to find R. So if we did that, your R for linear, go ahead and write these numbers down, would be negative 0.931. Quadratic, your R is 0.993. For log, you get an error message. And for cubic, you get 0.999. Which of these four is closest to 1 or negative 1? Cubic. So that will be my line of best fit. Or my curve of best fit. And then it says, what is the model for this data? The model is very long because for cubic, you need ax cubed plus bx squared plus cx plus d. So cubic is really long. We're not going to go through all that because a lot of it's decimals. But let's talk about number 10. Number 10, it tells about a tree that's in DC. It tells us to determine the log regression model, so that's what I'm using, to represent this data. Let x equal 0 to represent the number of years since the year 2000. All right, this is very important. Whenever you have years, you never put years in your L1 or your L2. So this is going to be L1, your height is L2. Okay? But they told us let 0 represent 2000. So if 2000 equals 0, 2001 will equal what? 1. What about 2002? 2. And 2003 will be 3, and so on and so on. So go ahead and cross out all your years and replace them. And we can never put years into our calculator. It does not work that way. Okay, you don't have to actually type into your calculator, but I want you to, we're pretending that we are. So let's say for my L1, we typed in 0, and then actually we don't even need 0. We need 1, 2, 3, 4, all the way to 11. My L2 would be my height. They told me to use my log function. The log function is basically ln. Okay? In your calculator, your log function will give you y equals 6.1, write this down, plus 6.1 times ln times x. So it says that they determine the height of the tree in the year 2015. I am not going to plug in 2015. What's my x going to be? Huh? It's going to be just 15 because we know that 2000 represents 0. So in your calculator, I want you to type this in and tell me what answer you get. But instead of x back here, you're going to type in 15. So 6.1 plus 6.1 times ln times 15. Does it get anything yet? I'll type it in mine too. So we had 6.1 plus 6.1 times ln. Remember your ln is right beside the 4. And then we're doing times 15. And you should get 22 times 6. 1. So my y would equal, I'll just round it to 23 feet. All right, I have one more problem to show you, number 11. On number 11, it says, find the exponential equation that models the following data. So this would be L1, and this would be L2. This is back to what we talked about, reading the directions and then reading all your answer choices. I know I need an exponential function, right? So let's go through and name which ones are exponential and which one are the others. What about letter A? I have x to the first power, so that would be what? This is linear. What about letter B? Exponential. What about C? It says 0.5. I think that's supposed to be linear, because if you round it, you still get 1. So x to the first power. And then D, x to the third power is what? Cubic. They're telling me to find which exponential equation works the best. I can find this answer without any work. What is it? It's D. I don't have to do any work there. Okay, so always look at your answer choices. All right, so your homework is homework E. Homework D will be extra credit if you do it. And I mean do it correctly. I know it's all multiple choice, so you can't just turn in circled answers and get credit for it. But if you want to try homework D and get, do some things right, you can earn some points there. But your homework is going to be homework E.